rationalizing denominators just means that you're trying to get the radical out of the denominator. You don't want a radical, square root, cube root, whatever in the denominator. We're going to focus on square roots. So if I end up with, for example, a problem that has a square root in the denominator, to get it out, I want to actually multiply top and bottom by whatever that radical is. If they're both under radicals, you can multiply those together. If they're not, the number stays out in front. The reason you pick the same number, though, is because now you've created a perfect square. So when I take the square root of a perfect square, I can go ahead and do that to simplify. So the square root of 49 is just 7. A lot of times people will jump this step here and go right to here. When I multiply a number, a radical times itself, a square root times a square root, the radical comes off. All right? That's kind of a shortcut way. This is what really happens. So if I have, for example, 5 over square root of 10, and I multiply top and bottom by the square root of 10, right, so straight across 5 radical 10, square root of 10 times itself is just 10. But now you can still reduce. The number part in the numerator will reduce with the number part in the denominator. So 5 goes into 5 once, and then 5 goes into 10 twice. Or you could write it simply as square root of 10 over 2. Because these are both not under radicals, you can't cancel the 2 and the 10 out. So at this point, either this or that would be your final answer. For this last example, if I have 2 square root of 3 over the square root of 5. And again, the goal is to rationalize the denominator. So I'm not worried about the radical in the numerator. I'm worried about the denominator. So again, multiply top and bottom by whatever that radical is. And the reason for that, again, is square root of 5 over square root of 5 cancels out to 1. So I'm only really multiplying the radical by the number 1, or the fraction by 1. So it's not changing it. Square root of 5 times square root of 5 is the square root of 25, which is just 5. On top, though, I can multiply the radical 5 and the radical 3 together. They're both under square roots, so that's the square root of 15 with the 2 out in front. At this point, there's no further canceling because, again, the square root of 15 and the number 5 aren't alike. They're not both under radical symbols. So this would be your final.